Now we are going to discuss about Flynn's classification. So it is based on the classification is mainly based on multiplicity of instruction and data streams. So in digital computers may be classified into four categories according to the multiplicity of instruction and data streams. So before getting to that, we should know what is the instruction stream, what is data stream. An instruction stream is a sequence of instruction as executed by the machine. It is a set of instructions one by one. So a data stream is a sequence of data including the data may come from input device or partial and temporary results called for by the instruction stream used in the instruction execution. Now we see the four types. So there are four types of Flynn's classifications, that is machine organization. First one is the single instruction stream, single data stream. It is called as SISD. Single instruction stream, multiple data stream, SIMD. Multiple instruction stream, single data stream, MISD. Multiple instruction stream and multiple data stream. It is called MIMD. Now we discuss each machine organizations one by one. So the first one is SISD, single instruction and single data stream. It is like a sequential machine organizations. So before getting to that, we should know what are all the computer components are involving in executing the involving in the instruction execution. The first one might be the control unit, that is control unit and processing processor unit and memory module. So in general, first we see what are all the steps involved in instruction execution. So mainly the first instructions are stored in a memory module. So the program counter gives the first starting address of the instruction. First instruction, it will be the memory address of will be given by the MAR. So the read operation will be initiated. The data will be, the instruction will be fetched and go to the MDR. So then it goes to the control unit. The control unit decodes that instruction and see what are all the control signals need to be executed to perform that execution of the instruction. Then the instruction goes to the processor unit. So while executing the instruction, if it needs some operands which are already stored in the memory, so the operands are fetched from the memory. While after executing the instruction, if the results want to store into the memory, the results had to be stored into a memory, back into the memory. That's why, see here, this line is, so the data, this is a bidirectional because the data will be, sorry, bidirectional. So the data will be moved from the processing unit to memory module and memory module to processing unit. But see this line, it is a unidirectional because the memory module only will provide that instruction at any point of time. The processor won't store the instruction into the memory. So these arrows are important. You have to be clear with what is the bidirectional, when the unidirectional will happen. So the connection between the processing element, processing unit to the memory module is bidirectional because the data, the operand values may be while instructions are getting executed, the operand values are getting fetched from the memory. After executions, the result might be stored again back into the memory module. That's why it is bidirectional. So now we see that first type, SISD, single instruction, single data. So only one instruction will be executed at a time. So yeah, operated on that particular one instructions also operated on only one data set. So we need only one control unit to decode that instruction set, and we have only one processor unit and one memory module. That is enough to execute this SISD format. Okay. Next one, next to machine organization is SIMD, single instruction, multiple data stream. So to parallelly execute on a multiple data sets, so we have divided that memory module memory module in memory shared memory into a number of memory modules. Each memory module might be attached to the one processing element. It provides the data to a particular element. So only one instruction. So the instruction set will be go to the control unit. So as we have only one instruction stream, one control unit is enough to decode this. After decoding that instruction, that single instruction will go to all the processing element parallelly. All the processing element, the PU1, PU2, etc. up to n will receive the same instruction that has been broadcast by this control unit. But the thing is that it operates on different data streams. You consider that example. So I want to calculate the total mark of each student in a class. So the code for calculate that or the steps for calculate the total is same. But the code for calculating the total has to be executed on student 1, student 2, student 3 up to n students. So it is a data set is different, but the code is same. That is the code is going to calculate the total marks of the student. So I want to execute the same code which is used to calculate the total to all the data streams. It means that all the student marks. It may be a combination of Tamil, English, Maths, EVS, computer science, etc. Okay. So the instruction set is same, but it has been operated on different data sets that will be provided in the memory modules which is available in the shared memory. The memory module is shared of all the processing element. Okay. So this single instruction set has been decoded by the control unit. It has been broadcasted. So as we have a single instruction set, one control unit is enough. Okay. So the next technique is MISD, multiple instruction, single data. So I have a different programs, but it is going to operate on same data. Okay, so I am having the total, the marks of the particular, I mean entire marks of the particular class for all the subject I have. Okay, so I have a mark of the class, entire class, but I want to find the highest mark. Okay, highest mark in language 1, like that lowest mark in language 2, average mark of language, I mean language 1, etc. So it is going to operate on the same data set, but the programs are different. The instruction sets are different. The first instruction is going to calculate the highest mark of language 1. The second program is calculate the lowest mark. The third one is the average. Okay, so the programs are, the instruction sets are different, but it is operating on the same data set. Okay, so see here, as we have a multiple instructions that has been given by that memory module, for decode that instruction, we need a number of that many number of control units. So we have a more control unit to execute all the instructions parallelly. So we need that many number of processing elements. Okay, so here we have a memory module, shared memory module. It transfers the same data. Okay, the same data has been given to the processing element 1. So here the connection is missed. The same data has been transferred to processing element 2. The same data has been transferred to the processing unit n also. Okay, so same data has been transferred to all the processing element, but the processing element receives the different instruction. So that it sometimes the result of the one processing element may be the input to the another processing element. That is also possible here. So the output of this processing element 1 might be the input of the processing unit 2. That is also possible here. So as it is, these are independent, the processing element 2 need to wait for the processing unit 1 to complete its instruction execution. Then only it can take the output of this processing unit 1 to processing unit 2. So as we are operating on multiple instructions, we to decode those many instructions we need the number of control unit. Okay, that goes to the processing element, but the data sent by the memory module will be same. The next one, multiple instruction, multiple data stream organization. So here multiple instructions. So we need to decode that multiple instructions. So we should have a multiple control unit for that. This control unit 1 is processing the instruction 1. This is instruction 2. It is instruction and etc. So to execute each instruction, we need that different processing units. So to execute that instruction stream 1, we need the processing unit 1. So execute the processing unit 2, we need the instruction stream 2, etc. Like that, each processing element is processed on working on different data sets. See here, it is the data stream 1, it is the data stream 2, it is a data stream 2. So each it are operating independently. This processing element is, for example, operated on program 1. So for example, the processing unit 1 is calculating the highest mark. Okay, mark of language 1. This processing unit may be calculating the average mark of subject language 2. This processing unit may find the total of subject 3. Okay, so the program is different, that is instruction set is also different. The data set is also different. Okay. So here this MIMD is called as tightly coupled, that is called as it is called as tightly coupled if the degree of interaction among the processor is high. If there is a highly interaction among the processor, this MIMD system will be called as tightly coupled. Otherwise, it is called as loosely coupled. Okay. It is only depends on the interaction among this processing unit, not on control unit or memory. Okay. If the processing elements are having a high communication among them, high interactions among them, okay, then it is this MIMD will be called as tightly coupled. Otherwise, it is called as loosely coupled. This is about the Flynn's classification. All the 4 types we have discussed. Okay, so the bidirectional, unidirectional arrows also very important. Okay, thank you.